Hello students, welcome to Vetri Neet Gateway. So already we have saw 5 videos related to the class 9th chapter 7 motion, right? So if you didn't see the last 5 videos, we will provide you the videos links in the description. Kindly see that 5 videos. After seeing that, you can go on to the part 6 video, which is kinematic equations. So we have already saw some basic parameters of motion and the problems on motion and graphical problems. Here we are going to see the kinematic equations. So what is kinematic equations? We can also call it as equations of motion. So to study the motion, you should aware about some equations. These equations will help to understand the motion of an object. Okay. So let me describe this, listen carefully. Okay, so these kinematic equations should be applicable to all cases. Whether these kinematic equations is applicable to all cases? Not at all. Okay, so kinematic equations will be applicable only to the body which undergoes uniform acceleration. And the object should travel in a straight line. These are the primary conditions to apply the kinematic equations. Wherever you should apply the kinematic equations, the object or the body should undergo a uniform acceleration. Then the path of the body should be in a straight line. So understand this. When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during the motion and the distance covered by it in a certain time interval by a set of equation known as equation of motion. When a body is in a uniform motion in a straight line means we can have the possibility of relating the velocities, time, displacement, initial velocity, etc. It is having the possibility of relating all other together. Okay, what is the relation between them? V is equal to U plus AT. This is the very first kinematic equation. Okay, and S is equal to UT plus half AT square. This is the second equation. And V square minus U square is equal to 2AS. Okay, we all know that V is called velocity, but here it is a final velocity. What is U here? U is nothing but what? Velocity, but it is an initial velocity. And A is what? Nothing but acceleration. And T is what? Time. Then S is nothing but displacement. Okay. So is there any other quantities? So same U also initial velocity, T is time, and then S is also here also displacement. These are the parameters we can relate it when the body moves along a straight line with a uniform acceleration. Got it? Students, kindly remember the 3 formulas. What are they? V is equal to U plus AT, first equation. Second one is S is equal to UT plus half AT square. And third one is V square minus U square is equal to 2AS. So now, is there any object with uniform acceleration occurs naturally? So my question is there any object undergoes uniform acceleration in a straight line naturally? Yes. If you leaving an object from I'm leaving this object. What happens? The pen drops down. Who attracted the pen? The earth attracted. That is due to gravity, right? So the motion under gravity is a best example for uniform acceleration. So that also travels in a straight line. So listen very carefully. One of the best examples for applying the uniform motion in a straight line is, so that is occurring naturally, it is a motion under gravity. So these are influenced by the gravitational force, typically in a vertical direction. Okay, here the acceleration is nothing but what? The value of acceleration. What is the acceleration? This is the acceleration due to whom? The acceleration of the body occurs due to gravity, right? So acceleration due to gravity we can represent as G. G is equal to 9.8 meter per second square. Got it? So this motion under gravity, there are two special cases. Motion under gravity. One is freely falling body. Freely falling body. Shortly we can call it as FFB in short form. Another one is vertical projection body. Vertical or vertically projected body, VPB. Okay, one is what? Freely falling body, and another one is vertically projected body. These two are comes under motion under gravity only. Freely falling body means I am holding this pen right now here. If I just leave means what will happen? It just fall down due to gravity. So freely falling means it's freely fall. I am not giving any velocity or force to fall. I am just leaving the pen. What happens? The pen drops down. Yes or no? So this is the example for freely falling. What is vertical projection body? So if the pen is thrown upwards means what will happen? Whether it moves on? No. It will stops at one point. It will stops at some height. After reaching the maximum height, it returns back. Yes or no? This also influenced by what? Gravity. Who made them to stop? The gravity made them to stop at a certain height, right? So it is influenced by gravity only. So okay. So we can see this in detailed manner. Yeah. First one is freely falling body. See here, a girl with a woman in a parachute is falling freely. Okay, so his acceleration is how much, pa? 9.8 meter per second square. Okay, so freely falling body means an object falls from a height with no initial velocity. So listen very carefully. Whether I am giving any velocity to fall? No. Whether I am giving any force to make this pen to fall downwards? No, not at all. I am just leaving it. I am just holding it. After releasing it, what happens? It falls down. Whether I am giving any force to move down? No, not at all. So the initial velocity in the freely falling body is 0. Initial velocity means u is equal to 0. Keep this in very mind. Okay, under the influence of gravity only. So initial velocity is how much? U is equal to 0. Acceleration is how much? Whether it is acceleration is due to whom? Gravity only, right? So the object falls downwards only, and the acceleration is also acting, the gravity also acting downwards. Both are in same direction. So plus G or G. Okay. So what is the first equation? V is equal to U plus A. T. Yes or no? In freely falling body, U becomes what? 0. So V is equal to U becomes 0, A becomes G. So V is equal to GT. This is the first equation. Keep this in mind. Okay. So what happens to U? In freely falling body, U becomes 0, right? So A becomes plus G. So V is equal to GT. Same way, what is the second equation? S is equal to UT plus half AT square. Am I right? Yes. What is U here? 0. So the whole term becomes 0. And instead of A, you should put what? G. So remaining is S is equal to half GT square. S is equal to what? Half GT square. What's the third equation? V square minus U square is equal to 2AS. In freely falling body, U becomes what? 0. So A becomes G. So V square is equal to 2GS. Okay. So if the question asked, if I thrown a velocity from not throwing, if I am leaving the velocity from a certain height, for example 10 meter, so a body was released from a top of the tower, from above the ground is 10 meter. What velocity it will strikes? We know the velocity V is equal to 2GS. 2 into 9.8 into what is the displacement? That height of the tower, 10. So we can see this problem, how we can apply this. Okay. Next one is vertically projected body, VPB. Vertically projected body. Okay, so an object is thrown vertically upward. Here what happens? an object is thrown vertically upwards from ground. If you want to move the body upwards means you should give some velocity, right? In case of freely falling body, if the body want to move from upward to downwards means you just need to leave only, because acceleration due to gravity, the gravity attracts the body. Here, whether if we keep this, it will move upwards without giving any velocity? No, not at all. I have to give some velocity to move this upwards. Okay, so listen carefully. This ball is moving upwards some with it. I want to give some initial velocity. For example, 10 meter per second I am giving. Whether its velocity goes on increasing after reaching the height. When increasing height, whether the velocity going to increase? Not at all. Listen very carefully. The ball is moving upwards where the gravity attracts towards the downwards. The motion of the body is upwards, but the gravity attracts it downwards. Okay, the gravity attracts it downwards. So what we can say here it is, here the acceleration is due to gravity only, but it is opposite sign. So A is equal to minus G. Here U is not equal to 0, because we have to give some initial velocity to move upwards. Without giving velocity, whether the ball move upwards? Not at all. We need to give some velocity to move upwards. So after giving velocity, what happens to the velocity? Whether it increases or decreases? The velocity is going to decreases. Velocity decreases. Why ma? Why it is decreasing? Because the object was pulled by the gravity. You are throwing upwards, but oppositely it was pulled by someone means its force, its velocity will decreases, right? So velocity becomes decreases. At the maximum height, this, consider the ball goes this maximum height. At h max, its final velocity becomes 0. Its final velocity becomes 0. If the velocity doesn't become 0 means, what will happen? The velocity, the ball keeps on moving upright. So if we are throwing an object upwards means, it returns back to the earth. It returns back to the ground. Why? Because we have not given the enough velocity to move upwards. Okay, so after reaching the some maximum height, it will return to the ground. Okay, so at the maximum height, what is the velocity? 0. So the final velocity is 0. So listen carefully, here acceleration is minus G. Gravity opposes the motion upward. At the highest point, the velocity is 0. Very, very important. Okay, so listen first, what's the first equation? V is equal to U plus AT. At the highest point, final velocity is 0, right? So V is equal to U. Instead of A, you should put what pa? Minus G T. So U is equal to GT. U is equal to GT. First equation. What's the second equation? S is equal to UT plus half AT square. Here what happens? S is equal to UT minus G, right? So minus half GT square. This is the second equation. What's the third equation? V square minus U square is equal to 2AS. So 0 minus U square is equal to minus 2GS. Instead of S, what you can put? It is the maximum, right? 2G H max. So at H max only velocity becomes 0. Here also we can put, okay, but we are not using the final velocity here. So here we are using the final velocity. Why we didn't put S as H max here? We didn't use the final velocity here, but we are using the final velocity here. We are using the final velocity as 0. When the final velocity becomes 0 at H max. So minus minus cancel. U square is equal to 2G H max. So make it clearly. This is the third equation. Okay. So if you know the concepts very well means you need to remember only 3 formulas, the 3 equations of motion. After remembering the 3 equations of motion, what you want to do? Apply the freely falling body concepts and vertical projection body. In freely falling body, what you have to remember? You remember that you didn't give any velocity to fall down. You are just releasing. You are releasing the body. It just falls down. So the initial velocity is 0. So keep that in mind. And acceleration is the motion of the body, and the acceleration due to gravity both are in same direction. So acceleration is plus G. In case of vertical projection body, keep remember in mind, You need to give some initial velocity to move upward. So here not u is not equal to 0. At the maximum height, what will happen? The velocity becomes 0. So at maximum height only, the final velocity becomes 0. And the very important point here it is, acceleration due to gravity is is opposing the motion. Acceleration due to gravity is doing what? It is opposing the motion. How? The motion of the body is upwards, but the gravity attracting downwards. Both are in opposite direction, right? So we are putting A is equal to minus G. So apply these two concepts in the kinematic equations, then you can get this. Okay students, till now we saw the basic understanding about the kinematic equations of motion. So in the next part, the next video, we are going to discuss the problems based on the kinematic equations. So hope you enjoy. Thank you.